Welcome, everyone. In today's worksheet, we'll be looking at a few problems um, tackling related rates, as well as the mean value theorem and Rolle's theorem, right? Um, Feel free to pause at whatever moment you would wish the video, so you can just sort of check your answers and attempt it on your own, right? So let's have a look at question one here. So question one is telling us that we have a certain triangle um, that has a length on one side, right? That is 3 times the length of the other side, okay? And we're basically asked that if the shorter side is decreasing at the rate of 2 inches per minute, or at this point you could just put 2 inches per minute or 2 centimeters per minute, so don't really um, stress too much about the units here. It's all about the concept. So if the shorter side is decreasing at the rate of 2 inches per minute, at what rate is the longer side increasing? Okay. And the way we'll do this is we'll say, well, let's maybe sorry, let me just change this. So let the shorter side be some y, some x, sorry. And then let's let the longer side be some y, okay, unknown. Now, what the question is telling us, right, is that the shorter side is decreasing at so the shorter side is decreasing at a rate of 2 inches per minute. So what does that mean? Remember, in our case here, the shorter side is dx. So all it means is dx over dt, the change in x over time, is decreasing, right? So it's a minus 2 inches per minute. Okay. So that's what the rate here means. So you need to pay attention to these the way the question is phrased, okay? So now we want to find, right? So knowing this, right, the question is asking us, what is dy dt? Okay, so that's what you're trying to find for sub question A. Okay, so we're given the rate at which x, which is the shorter side, is decreasing, and we're asked to find the rates at which the longer side is decreasing. So another thing that we're given, right, in the question is that the length of one side, right, is 3 times the length of the other side. So we could say that y is equal to 3x, right? And if you were to differentiate this in terms of t, right? Because remember, our variable here is time. So it would be your dy dt, okay, is equal to 3 times dx dt, okay? And since we're already given that dx dt is equal to minus 2, this is just equal to then minus 6. Minus 6 watts, minus 6 inches per minute. Meaning the longer side, which is y, is decreasing at a rate of 6 inches per minute. Okay, so that's for sub question A. So sub question A. So now let's look at sub question B. So here we're being asked at what rate is the enclosed area, right, is decreasing, right, when the shorter side is 6 inches long and is decreasing at basically the same rate as the one given in sub question A. Okay, so here we have a rectangle. What's the formula for the enclosed area of a rectangle? We've already defined what's the shorter side and what's the longer side, excuse me. So knowing that, we also given, right, in this question that x is equal to c, right? And sorry, just let me insert an equation. And we also given that dx dt, which can be written as x prime, right, is equal to minus 2, right, inches per minute. So we know that the area of a rectangle is given by the following formula. So A, which represents our area, is just equal to xy, length times breadth, right? Oh, yes, length times breadth. But remember that from sub question A, right, we're given that y is equal to 3x. Y is decreasing at sorry, y is 3 times the size of x, okay? So then we have this is basically equal to 3x squared. That's the area, right? So now, what would happen if we were to find the change of A over time, right? Which is dA dt, also can be written as A prime. So when you do that, you have to use chain rule, okay? So the constant comes back, then the x squared, the 2 comes down, right? So it will be the constant multiplied by a 2. Let's put this in brackets. And then multiplied by x, right? Which is then multiplied by dx dt, right? I'm sure you guys are aware of this from your exercises on chain rule, okay? This can be simplified to be 6x dx dt, right? And we're already given what is dx dt, right? Dx dt is equal to minus 2. So you have that this is equal to 6x times minus 2, which is minus 12x. Another thing that we were given is the value of x is 6, right? So when you multiply minus 12 by 6, you get minus 72, right? So now, what does this mean, right? Let's just put the units here. Always remember the units. This is inches squared per minute. And if you were to explain this in like verbally, you would say that the area is decreasing at a rate of 72 inches per minute, knowing what everything was given to us, right? So that is it for question 1. Looking at question 2. So what's happening in question 2? So we have 2 people that are at some elevator, okay? And at the same time, one person starts to walk away from the elevator, right, at a rate of 2 feet per second, and the other person starts going up in the elevator at a rate of 7 feet per second, right? And we are basically asked to find the rate at which the distance between the 2 people is changing 15 seconds later. Okay, so let's try to maybe illustrate this a little better. So this figure here kind of shows you what it should look like, but maybe we should also try to illustrate a small drawing what we actually meaning here. So you basically have some sort of triangle that looks like this. And the top part here, if you look at the um, if you look at the figure that's just above, this is the, oh, sorry. This is the elevator, right? Let's call it E-lev. And then the height obviously is Y, and um, the length here is X, right? And here, at this end here, we have a person, right, on the ground, right? So person on the ground. Okay. And we can call this side, which is the hypotenuse, as Z or Z. And we are given, right? Remember, we are given that what are we given? we are given that dx dt, right, is equal to what? Is equal to 2. Remember from the problem, it says that one person starts to walk away from the elevator. So if the elevator is here and you're walking away from it, excuse me, then you are going in that direction, right? So if I were to put an arrow there, you're going in. Let me just yeah. Let me just move around some stuff here. For more clarity, let's just move this down here. And let's raise this. Oh, okay. So let's just write it down there and then. So we're given that dy dt is equal to 2, but dx dt is equal to 2, but we also given that dy dt is equal to 7, right? And what they're asking us, right, is the distance between the two people changing, the rate at which the distance between the two people is changing. So what's the actual distance between the two people? Well, that's the z here. So they're basically asking us, right, what is dz over t? When t is equal to, because remember we're given when t is equal to 15 seconds. That's what they're asking us. So how do we approach this? So we're going down here. So if you assume that the two people are starting at the same point, right? So what does that mean? Well, it would mean that using the rules that you guys should know from high school, Pythagoras theorem, the hypotenuse is equal to the sum of the squares of the two sides, right? So we know that. So what happens when we differentiate with time this equation? So let's copy that and see what happens. Well, on the left-hand side, you would get the 2 that comes down, multiplied by z, multiplied by dz over dt, right? Being equal to 2x dx over dt plus 2y dy over dt. Okay. Now remember, we're trying to find dz over dt, okay? So dz over dt then becomes, when you're solving for dz over dt from the previous equation, what you get is, if I can simplify dx over dt as x prime and dy over dt as y prime, then what you get is 2. So let me just open a parenthesis. 2x x prime plus 2y y prime all divided by 2z. And we can clearly simplify the 2 for this to become that. So what is that equal to? Because remember, this differentiation is in terms of t. So what is that equal to? Well, first we need to find what are the values of x and y when t is equal to 15, right? So we're already given that dx over d2, for example, dx over dt is equal to 2, right? That means that at t equal to 15 seconds, you have that x is equal to just 2 times 15, right? Because you're looking at the change in time from 0 to 15. So x will just be equal to 2 multiplied by the 15, which is equal to 30. Whatever unit it is. I'm not sure if they gave us a unit. Yes, 2, so 30 feet. Okay. And then y, if we repeat the same process for y, remember that we're given that y is dy dt is equal to 7. So here we have dy dt is equal to 7, meaning at t equal to 15, we have 7 multiplied by 15, which should give you 105 feet, right? So now, knowing these two, you can also calculate what is z, right? Because remember, you have that c squared is equal to x squared plus y squared. And what this means is that z is just equal to the square root of x squared plus y squared. And what is that equal to? We have x, we have y. It's just basically equal to the square roots of 30 squared plus 105 squared, which if you do the calculus, you should get 15 multiplied by the square roots of 53. Now we know x, we know y. Just change this. Now we can find, and we know z as well. Now we can find dz dt, right? So going back to our equation, this is just equal then to our x is 30, so 30 multiplied by 2 plus 105 multiplied by 7 all divided by 15 multiplied by the square roots of 53, which should give you a value of 7.28 feet per second. Right? So let's just put square brackets here so it doesn't look like we're saying 105.7. And here is what we have. Okay. So that is it for question 2. Now, if we go to question 3, we have that a person is standing 350 feet away from a model rocket. Okay, so we'll have to draw that again to sort of illustrate what we're talking about. So the person is 350 feet away from a model rocket that is fired straight up into the air at a rate of 15 feet per second. Okay, so this is important, 15 feet per second. And we are asked to find the rate at which the distance between the person and the rocket is increasing. First, 20 seconds after the liftoff, and then second, 1 minute after the liftoff. So it's basically more or less repetition of what we did for question 2, right? So let's go through that. So let's say we have, once again, a triangle looking like this, illustrating our problem. So the rocket is being shot straight up. So it's somewhere here. Okay. The person is at this end here. I'll just call them P. So you guys should know it's the person. And this side is the height, Y. This one is X. Oh, sorry. This one is X. And then that one is Z. We're given already that the value of X is equal to 350, right? Because remember, it says that the person is 350 feet away from a rocket. So we consider that to be the horizontal distance between the person and the rocket, right? And that is given to us to be 350 feet, okay? So once again, we are also given, here I can insert an equation. we're given that dy dt, right, which is the rate at which the rocket is flying up. Dy dt is 15 feet per second. And then, what are we given as well? No, we're asked to determine z prime or dz dt, right? For each given time. And these are the two given time, right? So A and B. So now remember that we know from the previous problem and Pythagoras theorem that the hypotenuse squared is just equal to the sum of the squares of both sides. Okay. We're already given x. So if you substitute in the value of x, this basically equals to y squared plus 350 squared, which should be 122,500, 122,500, right? And then now remember we're trying to find dz dt, right? So we can differentiate this equation in terms of t. And what happens when we do that? We have the 2 that comes down on the left-hand side, multiplied by z, multiplied by dz dt, which is equal to 2 that comes down, multiplied by y, multiplied by dy dt, right? Plus the derivative of a constant, which is just 0, right? So this is what it's equal to. Right off the bat, we can simplify by eliminating the 2. So the 2 can already be cancelled on both sides. On the right-hand side, we already know what is dy dt. It's given to us to be 15. So we have 15y on the right-hand side. And if you were to solve for dz dt, right, which is what we're trying to find, you have that dz dt is equal to 15y over z, right? So all we would need to do is find the value of y at 15 seconds, right? After 20 seconds. So you just multiply the 15 by 20, you get the value of y at 20 seconds. And then you can get the value of z at 20 seconds, right? And then you can just substitute it into this, right? And get the value of dz dt, okay? So that is a pretty straightforward question. Now, that is the end for question 3. Moving on to question 4. Let's just make some space here. So we're given that a thin sheet of ice is in the form of a circle, okay? And the circle is melting in such a way that the area of the sheet is decreasing now at a rate of at the rate of 0.5 meters squared per second. And we are asked to find the rate at which the radius is decreasing when the area is equal to 12 meters squared. Now, two things here. So first we can say, let's represent so let's represent the area of the circle with A, right? So as soon as we do have that, then we know that dA dt is equal to dA dt is equal to 0. No, remember decreasing, so minus 0.5 meters squared per second, right? We also know that the area of a circle is given as pi r squared, right? So now if you were to differentiate this formula for the area, what do you get? Well, you would get dA dt is equal to pi multiplied by 2, right? The 2 comes down, multiplied by r, multiplied by dr dt, the change in radius over time. Now, in this case, the question was we needed to find the rate at which the radius is decreasing, right? When we're given a specific area of the sheet, right? So in this case, we are actually solving for dr over dt, right? So dr over dt is therefore equal to, I'll just represent d over dt by a prime. So a prime divided by 2 pi r. So now from this formula here, we're given that a is equal to pi r squared, right? And for a given value of a equal to 12, right? Just like in the problem, we can find the value of r squared. Okay. So in other words, r squared, or r, is basically equal to the square root of 12 divided by pi. And that should be equal to 1.954. Now we have that. We can already estimate what the value of dr over dt is equal to. So let's do that. So knowing a, knowing r, we can say dr over dt is the change in a, which is minus 0.5 divided by 2 pi. So 2 pi multiplied by the radius, which is just 1.954. Right? If you estimate this, you will get that the value is equal to minus 0.041. And that would be meters per second. So basically, the radius is decreasing at a rate of 0.041 meters per second. Now, moving on to question 5, we're given, that we have a tank, right, that is in the shape of a cone that's being filled, right, with water at a certain rate, 12 meter cubed per second, right? We're given that the base of the tank has a radius of 26 meters. The height of the tank has a length of 8 meters. So maybe we should try to illustrate this on the next page. So if this is representation of our cone, right? And if you were to draw a line going through the middle, we have that this value here from the middle to the edge, which is the radius, is equal to 26 meters. But also, we're given that the total height of the cone-shaped tank, from top to bottom, is equal to 8 meters. And what are we asked? We're asked that to determine the rate at which the depth of the water in the tank is decreasing, or rather it's changing, when the top radius of the, when the radius of the top of the water is 10 meters. So if you could imagine it, as the cone is filling up, water is rising and rising all the way to the top, right? And the radius, right, which would be the distance. So let's say in our representation here that the water is reaching a certain level like this one. This radius that they're mentioning, the radius of the water, right, or rather the top of the water, is basically this distance here that we can call R. So that distance, as it's changing with time, so sorry, no. So we asked to find the rate at which the water in the tank is changing when the radius R is equal to 10. So we can also determine that whatever, let's say at this height, when the water is in the tank, at this height, we can just represent this height by the letter H. So we basically want to determine the value of H when R is equal to 10. And we're given that dV dt, right? So let me make some space here at the bottom. So we are given that dV dt, which is the change of volume over time, also can be represented as V prime, is equal to 12 meter cubed per, is it second or minute? per second. Now, we know what's the formula for the volume of a cone, right? Again, from high school, we know that the volume of a cone is V equal to 1/3 of the height multiplied by the area, which is pi, the area of the base, which is a circle, so pi r squared. We want to determine what is h prime, right? So let me just insert it maybe there. So we want to find what is dh dt, or h prime. Because remember, h prime is going to help us determine, well, that's actually what you're trying to find. You're just trying to find the rate of change of the depth, right? So we're just determining h prime. So if we were to if you use the concept of similar triangles, right? I'm sure you guys are aware with this. So for similar triangles, this radius here divided by, because remember, this right here, so going from the top of the conical tank to whatever the liquid is, right? That are all the way. So this whole thing here is actually a triangle, right? As I'm sure you can see, going from there to that and back down to that. So that is a triangle when you actually project it into the 2D space. And if you use rules for similar triangles, you can say that R over H, R over H of the small triangle is equal to R over H of the big triangle, which is basically 26 over 8, right? So what does this mean? Well, this means that knowing this rule from the similar triangles, we know, therefore, that R is just equal to 26 over 8, which can be simplified to 13 over 4 multiplied by H, which is a good development because then we can substitute it back into our equation for the volume, which then becomes 1 over 3 multiplied by H multiplied by pi multiplied by r squared, which is 13 over 4 multiplied by h. And this is just squared. It should get you 169 over 48, sorry, pi h cubed. And when you take the derivative of this on the left-hand side over time, right? So dv dt is equal to 169 over 48 multiplied by pi multiplied by 3h squared dh dt, right? Chain rule. Remember that we're given that r is equal to 13 over 4 times h. So if you know h, you can find r. From the problem, we're given that r was equal to 10 meters, right? So immediately, we also know that h is equal to 8r, rather 4r over 13, which is just equal then to, if you substitute in the values of r, you would get 40 over 13. Now, if you plug this into our dv, what do you get? Let's try that and see what we get. So we know what's pi, we know what is h now. 40 over 13. We were given dh of a, right? No, we're not given dh over dt, but that's what we're trying to solve. So if you just now solve for dh over dt using this equation, dh over dt is just equal to dv over dt all divided by 169 over 48 pi multiplied by 3 multiplied by 40 over 13 squared. And this, what does this give you? When you actually solve the entire thing, you should get that dh over dt is equal to 3 over 25 pi. And that is in units of meters per second. Okay? Meaning the height is changing, increasing at a rate of 3 over 25 pi of meters per second. Right. So now, if we were to move on to question 6. So this question is stating that the question is stating that we have air being pumped into a spherical balloon, right? And the volume of the balloon is increasing at a rate that is given, 20 centimeters cubed per second, when the radius is equal to 30 centimeters. And we are asked to find how fast the radius is increasing at a time when the volume, or the rate of the volume, is increasing at a rate of 20 centimeters cubed per second, right? So we're given a hint here, which is the volume of a sphere, right? So if you use that to find dv over dt, what you get is 4 pi right? 4 pi over 3 multiplied by the 3 that comes from the r cubed, so it becomes 4 pi multiplied by r squared multiplied by dr over dt. Now we're given dv over dt, 20, right? But we're also given r, which is 30. So basically all that we have to do now is find dr over dt. So the change of radius over time, which is equal to dv over dt divided by 4 pi r squared, which gives you what? When you plug in the values, you should get that dr over dt is 1 over 180 pi centimeters per second. Right? So that is a pretty straightforward question. So pay attention to those. Sometimes you might expect it to be hard, and so you panic and start solving.